In this video, we are going to talk about sinusoidal models. So sinusoidal models are just periodic functions, which means they continuously repeat in the same pattern. So sine or cosine functions is what we're going to talk about today. Now, our model is going to be y equals a sine bx plus d, or y equals a cosine bx plus d. Now, for the sake of this course, SL will always be in degrees. We will not be in radians. So the period is the length of the shortest interval in which the values repeat. So that is the horizontal distance from a max to the next max. So we're subtracting the x-axis values. Your principal axis, that formula is P equals 360 divided by B, where B is that value multiplied by x inside your sine or cosine function of the equation. Your principal axis is the horizontal line located exactly in the middle. So essentially, if you fold yourself on hot dog style. So that equation is d equals the y max plus the y min divided by 2. And in our equation, d is the value we add or subtract by. And then lastly, we have the amplitude. That is the vertical distance from the principal axis to any max or min. That is a equals y max minus y min divided by 2. And it is the value in front of either sine or cosine in the equation. Now, a key thing, memorize all of these formulas because they are not in the folder. So, how do we know if it's going to be a sine or a cosine function if they don't give us the equation? Sine, your midline of the function, is on the y-axis, aka that principal axis hits the y-axis. Cosine, your max or your min, is on the y-axis. So on this example, we are given a graph. We are also given the equation. We want to find the amplitude. So remember, the amplitude is the value in front of sine or cosine, and it is always the absolute value. So in this case, it says negative 20. So we could say, oh, there it is in the equation, but make sure you say 20 and not negative 20. The other way is the principal axis, that halfway between the max and the min. In this case is the x-axis. You go up all the way and then over to y. Both times we get 20. So our period. So two ways to find our period. The first is, again, that horizontal distance from a max to max or a min to min. So if we look from the min when x is 0 all the way over to the min past between like the 60 and the 80, subtract those values. That is option number 1. Option number 2 is to use our formula. P equals 360 and the B value inside the equation is 3. Either way, you should get P to be 120. So on this one, we are given our max and our min, and we need to find a lot of missing pieces. So first, find A, B, and D in our equation, and it does say our equation is f of x equals a sine b of x plus d. So first, starting with A, our amplitude, that's y max minus y min divided by 2, so 11.2 minus 5 divided by 2, and we get A to be 3.1. D is y max plus y min divided by 2, so 11.2 plus 5 divided by 2, and we get 8.1. So lastly, we have B. So we know B has a relationship with our period. So our period we know is one full cycle from a max to max or a min to min. So the question becomes, what is that relationship from a min to a max? That is half of the period. So find the length and multiply by 2. So we have 11.2 minus 5, and then multiply by 2, we get a period of 12. Now that we have the period, we can find B. So 12 equals 360 divided by B. So 12B equals 360, and we now have B equals 30. So then we want to interpret. So with our answers, A is the amount of depth that differs on average. And then D is that average depth. So the average is 8.1, and that will vary about 3.1. And then B is the amount of times the function repeats within 360 hours, which would be 30 times. So this last example, we are given the B value of our equation, but we don't have A or D. And in this case, they do say C instead of D, but it means the same thing. So the period of the function, again, we can do max minus max or min minus min, or use that 2 that is in our equation and do period equals 360 divided by 2, and we get the period of 180. For our amplitude, we are not given that in the equation, so we do need to do the y max minus the y min divided by 2. Our y max is 3, our y min is -1, so 3 minus -1 divided by 2, and we get a equals 2. So a and c, we need to find those values. Like we said, we couldn't use a in the equation, but we just solved for it and we got 2. C is the same as D, so y max plus y min divided by 2, which would be 3 plus -1 divided by 2. We get C equals 1. So then calculate the first negative x-intercept. Well, we know our equation is now 2 sine 2x plus 1. So we're going to put that in y1. y2, we're going to put 0. Find your intercept. And again, it is the first negative intercept, so we need to make sure that is the one we go to with our blinker. We get -15, so our answer is -15, 0.